Okay, we want to solve this equation. So this equation looks a little bit complicated, right? The denominator is to the power 4, numerator to the power 3. If we want, we could do the traditional ways, but maybe sometimes we want to find a shortcut. So for this one, what I would do is I would divide the numerator and denominator by 1, and this 1 is x squared over x squared. So I divide the numerator, basically I reduce the power. Because it's rational, I have a rational equation to deal with. I can always reduce the power if it's possible. So I divide the x squared in the numerator, divide the x squared in the denominator. So the numerator, when I divide by x squared, I have x plus 1 over x, or 1 over x, I can write as x raised by -1. The denominator, when I divide by x squared, I can push the x squared inside the square. Oh, this is missing a square. Okay, this is the original question. I have a square here. So this one, this is a typo. So this should have a square. Let me write a square here. So this should have a square. So if I want to push this x squared inside the square. So how do I do that? I just push x, right? Push x inside the square. So that means I divide by x inside the square. You see the square outside, right? I divide inside by x. So then the denominator divided by x before the square. So I have x plus 1 over x minus 1 squared. Now you see I have something in common. I have x plus 1 over x or x plus x raised by -1 in common. So that tells me, I can always treat these two terms as one thing. So now we can cross multiply on both sides. So we get a 4 times x plus 1 over x equals 3 times x plus 1 over x minus 1 squared. Now, I can look at x plus 1 over x as one variable. I call the variable k, right? So in this case, I can simplify my equation. So I can rewrite my complicated equation with x plus 1 over x as in k term. So I have 4k equals to 3k minus 1 squared. Now I can use perfect square formula to expand k minus 1 squared, which is k squared minus 2x plus 1. So simplify, I distribute 3, simplify both sides. So I combine the like terms on both sides, move around, move 4k to the other side becomes -k, -4k. So -6k minus 4k, that gives me -10k. Right, now I see the coefficient of k squared is 3 and the constant is 3. Oh, I'm thinking, okay, I should make this 3 multiplied by 3, then plus 1, that gives me 10. Indeed, we can factor this as a 3k minus 1 and a k minus 3. So 2 factors equals 0. Then by 0 property, I get a 3k minus 1 equals to 0 and k minus 3 equals 0. 3k minus 1 is 0, means k equals 1/3. And k minus 3 is 0, that means k equals 3. So I have 2 solutions for k. That means my x plus x over 1 has 2 solutions, right? 1 is 1 over 3. Then I can rewrite this equation. X plus 1 over x equals 1 over 3. I can multiply by x on both sides. When I do that, I get x squared minus 3x plus 1 equals 0. I use a quadratic formula, right? Quadratic formula, -b is -3 plus minus the square root of b squared -3 squared, which is 9, minus 4ac, minus 4 times a is 1 times c is 1. So I get 2 solutions, 3 plus minus square root 5 over 2. That's for k equals 1/3. For k equals 3, I have x plus 1 over x equals 3. I do the same thing. I multiply by, hold on a second. This, I think I did something wrong. So, because you see the 2 equations, okay, I gotta make changes. So this is 1/3. The first one is 1/3. So when I multiply by 3, I get 3x squared. Okay, let me make corrections here. So for this one, when I multiply by, I can multiply by x. Right? I multiply by x on both sides of the equation. I can write this way. Let me try to use my, then what do I get? I get x squared, right? Plus 1 over x times x is just 1. Then plus 1/3 of x, right? I move to this side, I get minus 1/3 of x equals 0. Now I multiply by 3. When I multiply by 3, I get 3x squared plus 3 minus 1x, right? So basically I have 3x squared minus x plus 3. And then if we check, this one doesn't have a real solution because the discriminant is -1 squared, which is 1, minus 4ac, 4 times 3 times 3, right? Which is a negative number, which is less than 0. But for now, we're looking for solutions in real number world. So this one has no solution, all right? This one has no solution. But when k equals to 3, we have 2 solutions, which we solved already. We should get these 2 solutions, 3 plus minus square root 5 over 2. So these are the 2 solutions for the equation. Hope this makes sense for you.